Before I introduce the next speaker, quick word from one of our sponsors. Prisma Cloud is the industry's most comprehensive CNAP with the broadest security compliance coverage for applications, data, and the entire cloud-native technology stack throughout the development lifecycle and across hybrid and multi-cloud environments. The integrated approach enables security operations and DevOps teams to stay agile, collaborate effectively, and accelerate secure cloud-native application development. With that, I want to introduce Jake Berkowsky with the next session, Normalization of CSP audit logs with open standards, how to search everywhere at once. Give it up for Jake.
Hi, everyone. Before I get started, I'm going to introduce myself. My name is Jake Berkowsky. I'm a Principal Cybersecurity Architect at Snowflake. I am also the field CTO for our cybersecurity workload. That's a fancy way of saying that I make up best practices, and then I steal them from people like you. So thank you all very much. Sometimes they let me talk. This time I didn't seek approval, so don't tell anybody. Before this, I used to do other things that involved regex. But now I'm here. So, quick disclaimer before I get started. This is a 20-minute conference talk on just general patterns, general architecture. I work for Snowflake, not a Snowflake-specific talk. In fact, it's not any kind of a back-end-specific talk. So if anyone is watching this, especially on YouTube, and they see me and they say, oh, I want to do this, do reach out to me, because, again, there are different patterns for different back-ends. Normalizing logs in object store, different pattern, right, for a data warehouse. So before we get on, what are we here to talk about? We're here to talk about piles of logs. And I know this is probably a really weird thing to say at a cloud security conference, but as security folk, we hate the cloud. We never wanted it. We don't like it. Steve Jobs said move fast and break things. Security people, I have an ops background, we say don't move. And if you have to move, just don't break anything. And so, but now we're here. We're at the party. We're at the party because we're kind of forced to be, because all the vendors moved to the cloud and all the people that we support moved to the cloud. And now we're here at the cloud and there's just like so much more data than there used to be. Like 10 years ago, we got a little bit and we're like, all right, we can do stuff with this. It's fun. And then like now it's just like way too much to do anything with. So we just don't. We throw it out. But we're here and we're storing our logs in places like object stores and we're using the data people stuff like databases. And we're no longer limited by cores. We can use serverless. We don't have a limit to how much data we can store unless we can blow up S3, which some of us here probably can. But we're able to do stuff we couldn't do before. We're able to do it way more cost effectively. But now we have to learn about data. We have to use the data people's toys, the things that we never really knew existed, the things that were extracted away from us. And one of those things that we have to do now when we start thinking about this is we have to think about normalization. We have to think, do we get data into a common schema? When are we going to do that? The short answer is sometimes. Not all the time, but sometimes. But why? Why are we normalizing our data? Why nowadays are we normalizing our data? So the first reason is pretty standard, right? You're kind of made to. Your SIEM vendor tells you, hey, this is how I accept the data. You're going to either wait for us to build the connector or you're going to build one and you're going to put it in like this, and that way the dashboards, they're going to light up real nice. Or maybe your boss tells you because you're a vendor and your boss is telling you, no, we need to normalize before we can bring it in because we're bringing in everybody's data. We have a lot of customers. So let's build a model together. It means that, why would you do it? Maybe you're writing detections and you want more generic detections. You don't want to necessarily have to write the same one for all of your different sources. So ideally, or in theory, it's more easy to do when the data is normalized. And that's not always the case, and we'll talk about that. And actually, it just makes it easier to know what you're querying, right? If you're in one of these modern data stacks, or you have all your data in a database somewhere, how do you know what is it? IP address, IP underscore address? Maybe you have back in the olden days, you just I'll just query the last 15 minutes of everything. Well, it's the new days, and the last 15 minutes of everything is not really feasible anymore. You got to have a little bit more knowledge on what you're querying. So having a standardized schema can help your analysts save time. But there's also just as many reasons why you shouldn't. In a lot of cases, it's not worth the time. Imagine that you have a compliance requirement. If you have a compliance requirement, just throw it anywhere. I mean, Glacier is an alternative to deleting things, so throw it there. But other reasons as well, right? It's not worth the compute cycles. You actually have processors, you have a budget. It might not be worth it to normalize all that data, even if it was worth your time to think about it. And another one is data is not compared to similar data, or it's already normalized enough. So I mentioned that I'm showing normalization of cloud audit logs. I didn't say with each other. And the reason for that is because normalizing cloud audit logs, it's controversial. And everything here is controversial, but this one also. It's one of those few services that, right, AWS Data Lake, Security Lake will actually support, but then when I talk to practitioners, right, support it being normalized in this OCSF format, we'll talk to a little bit later, they tell me like, well, I'm a threat detection person. I don't want my cloud audit logs normalized with each other. They're different clouds. I have different detections for AWS as I do for GCP. I'm not gonna deploy the same detection. Just because they don't, doesn't mean that an ad hoc team doesn't want to, doesn't mean that an audit team doesn't want to, doesn't mean that other teams don't want to, right? So it really is about what makes sense for you. The other thing I've heard, right, I only have 2 clouds. Why am I gonna spend all this time normalizing for 2 sources? We don't have N clouds, we have 2, maybe in a couple of years we'll have 3. Of course, the counter argument there is that if you do want to do maybe you're not prepared for it, but if you do need to do an IOC sweep, maybe it does make sense. And then I mentioned, right, maybe your data is normalized enough. So if you're an AWS shop, AWS logs are all kind of similar. Maybe they're already kind of grouped together. Maybe you don't need to go that extra step. So what I'm talking about today is a little bit, right, it's the when, the why, the where, and hopefully just touching on the top level of a little bit of everything. So when you get forced to think about these things, you know what questions to ask, and you don't want to, you're thinking in the right way, not I'm going to go pick one solution and run at everything. So this one's the only short slide, sometimes. Nobody does it all the time for everything. If anyone tells you we're going to normalize everything everywhere, they're not going to do it. It's a myth. For pretty much everyone, except if you're a vendor, and even then if it's a myth. If that's your product, maybe you'll get a little bit further. I mean, think about how hard it is just to enforce naming conventions. Imagine an entire schema across a bunch of different teams, across a bunch of however long it takes to build this thing out and however many people start and leave during that time. So keep that in mind. There is benefits. You're not going for everything. That's not the goal. It never was. Where? So this is an interesting one too. Where do you do your normalization in your pipeline? Again, we're not talking here back-end specific. I'm going to cheat, by the way. The answer is a little bit everywhere. There's no reason you have to choose. But sometimes you'll do it at the source. How much time I got left? Sometimes you'll do it at the source, right? So maybe your vendor, right? Prowler was up here before talking about how they released their logs in OCSF format. That's great, right? They'll offer it or a different standard. That's free. You're not doing anything. You're getting it in an open format, an open standard. That's awesome. So maybe you're doing it for that. And usually, right, you're not paying any more, so why not? Problem is, of course, when a vendor doesn't necessarily, I'm not picking on anyone in specific, but what if a vendor decides they don't want to maintain it anymore? About a year and a half, 2 years ago at reInvent, Amazon released the OCSF standard with Splunk, and as part of this big announcement and the announcement of Amazon Security Lake, a whole bunch of vendors who all, with the best intention like me, felt passionate about this, released something, right? Some of them kept up with it. Some of them went further. Some of them contributed more to the community. Other ones just didn't do anything. Their option for OCSF is a pre-release version in some unmaintained GitHub repo, right? So you're now a little bit more dependent. And maybe now just because you got it, you thought you had it at the source, you still got to do it in additional work, right? And that's not a bad thing. That's not a negative. That's a neutral, right? Maybe you have to do work, maybe not. So good gamble. But also you might end up forking later on down the pipeline anyway. Just because you like this one standard, just because your threat detection team likes this standard, doesn't mean that your compliance team, doesn't mean legal's going to like it, doesn't mean whoever else is using this data, your data scientists are going to like it. So you may have to transform it later anyway. Another kind of edge case is I work a lot at Snowflake with vendors who actually operate on top of their customers' data lakes. And in that regard, it's not the source isn't the tool generating the logs, but rather the SIM itself, which then has its own standard. So other customers will build downstream workloads using the standard by this SIM that exports into the data lake. I think we're still good on time. What else? There's the matter of format. People talk about, actually, am I still in the right spot? Yep, still in the source. So we're gonna explore this more in the demo, but let's just say we're getting normalization at the source and it's built to spec, right? You got a team that really takes it seriously, really follows through. To spec can mean different things to different people, right? If a log's outputted in JSON, that's great, but is it nested JSON? Is it flat with a period separating it? I mean, they're both technically correct, but I've seen different vendors implement their logs differently. And if your backend tool supports one but not the other, maybe, again, there's still work that needs to be done. And sometimes, even if it's perfectly to spec, no matter what you do, it's an intractable problem. Last I checked, right, Security Lake publishes CloudTrail logs in OCSF format in Iceberg. Company I work for just added Iceberg support, so I was really happy. We get together, we're like, we're doing this great work. And then we found out that they built to spec. They built milliseconds for their time stamp, which is to OCSF spec. Iceberg spec is microseconds. So already, both of us built to spec. We need to do more work to meet in the middle. So again, right, long way to say there's no easy button here. You can reduce your work. You're never going to fully eliminate it. Unfortunately, my prediction for everyone here is you're going to have to learn a little bit more data, kind of like the developers had to learn a little bit more ops. But hopefully, we can all do a better job. Okay, so where else can you do it? You could do it in the pipeline. A lot of people hear tools like Cribble, tools like Apache NiFi. That's great. There's specialized tools, security ETL tools that do it. Generally, right, that's a better cost to do it while it's in motion. Transformation's a little bit cheaper then. But again, right, what happens when things change? What happens when you need backwards compatibility? Then you're still going to need to figure out a way, once it's stored, to get it back into that raw state, right? What happens when that other team, that data science team, says, hey, I need it in the original form, right? So you'll do a little bit of this, but do be careful. Do take backwards compatibility into account. Always, at the end of all of this, if you have it in some sort of a database that allows views, just add a view at the end, just in case, even if it does nothing. Right? Make sure you're loosely coupling. That's something that I think you've all heard a million times. And then lastly, right, you could do it in the storage location. You can bring it into a database, you use the ELT transformation patterns. It's good, right? You keep it raw. You can use the views for backwards compatibility. And for data that's not commonly queried, you just never even have to worry about it. It's just sitting there queryable, maybe not as performant as it needs to be, but it's there. It's ready to go if you ever need it. Trade-offs there, right? Additional complexity. You need to maintain a bunch of pipelines. Probably, again, no one's naming anything, correctly and all of that. And you might end up with copies of data that cost money. So again, all of this is engineering. All of this is about trade-offs. So again, right, the answer is a little bit of all of these. Choosing a standard. Again, how would you choose a standard? My practical advice is don't overthink it. I'm not going to say it doesn't matter, but it's not the biggest decision you're making, right? Really, the decisions you're making are thinking about all the trade-offs, being thoughtful, right? Things change very rapidly, but a lot of times standards will help you get going. So your first option is to not choose a standard, right? Don't do anything, and that's not bad. You can still search. You can still write detections and alerts, or maybe you're not doing that. Maybe your SIM does that, so maybe you're just storing all the data and using it to build dashboards, right? And it's a million times better than it used to be, so you're good. This is tier one. You don't need to start with a standard right away, right? We're never going to get to that 100%, so maybe don't bother right off the bat. You can build it yourself. That's what most people do. A lot of times at Snowflake, we'll bring things into our internal security data lake. We'll pull out a couple of fields that we like. We'll create some views so that some things match, some things are nice. But a lot of things we'll leave raw. Some things we'll normalize more, right? And again, now you have the option, you can pick one. So we didn't used to have any, right? Now we have like two pretty decent ones. So the first is the Elastic Common Schema. Started by Elastic, it was donated to OpenTelemetry. For the most part, when I talk to customers that are doing an at-scale normalization of security data, and they've been doing it for a while, they've forked it, but they've based off Elastic Common Schema. This got recently, about a year ago, donated to OpenTelemetry. They're going to try to merge the two projects together, which could be really cool because OTel is huge in the observability community. But we haven't seen much progress yet there, so we'll see what happens there. And the other, OCSF, we've had a few people today mention it, and so this keeps coming up. So this is the new hotness. It's the new kid on the block. It is a good standard. It has a very non-toxic community. I see I'm part of that Slack. I see someone has an idea, wants to add something. Okay, let's do it. Let's work on it. So that to me is the one thing that makes communities grow. So things to consider, right? And again, you're not going all in. You're just going further. What else? There's other standards as well. Splunk's Common Information Model, Vulkan, all of those. So I think that is demo time. I got 5 minutes left, so I can demo and take a Q&A. So I'm going to showcase just kind of what these logs look like. So let's start off. Make this a little bit smaller. There we go. Let's start off with some raw logs. So Azure sign-in logs. They look like Azure logs, right? Nested, a bunch of things going on here, different formats, right? Nothing special there. CloudTrail logs look like CloudTrail logs. Hopefully this isn't the first time we're all seeing these. This one, right, it's actually CloudTrail, right, comes all grouped in one array in these files. So we have a little bit of weirdness going on there if we tried to import everything at once. And then, right, GCP logs, just for fun. I didn't even take a common audit log. I took an HTTP log, right? So we're going to show how this can be normalized. We're not going too deep here, right, because I just want to kind of illustrate these. So what happens when we normalize? Well, I haven't showed GCP yet, but let's take a look at a few different things. We take Azure. You can see this looks a lot cleaner, right? I'm showing this with OCSF format, by the way, but now we have common fields. I said, okay, let's do this flat. Snowflake can do nested JSON, but I didn't know what other platforms could, so I decided to make it as easy as possible, right? Flat JSON, separated by periods. We're able to see some things got added, some things got enriched, right? So, for instance, product name, Microsoft Azure, or Azure Sign-In. Vendor name, Azure, right? So we're starting to, okay, now we can have all these logs. We can kind of maybe put them together. Maybe we should, maybe we shouldn't. Which logs should we store together? That's a topic for a completely different talk. But let's look at CloudTrail, right? So this is when I mentioned, right, when Security Lake first came out, AWS said, okay, this is the pre-beta, we've released CloudTrail normalized, right? And we're seeing some of these fields. I'm showing this one with just for illustrative purposes, nested JSON, right? We still have, okay, this is an AWS, we have the region, the IP address field, that's normalized, but what we have here, unmapped, right? This means that they haven't gotten around to it yet, that it's not in the spec. These are the other, right? And boy, are there a lot of other. And okay, does it matter? Maybe, maybe not, right? Now, Amazon, since they're one of the leaders in the spec, well, that's pretty cool. They nowadays, a lot less unmapped, right? But again, your other tools, other categories that aren't audit, that don't have companies sponsoring them, may have a lot of these unmapped fields. And what are you going to do? You're either going to ignore it or you'll map it. Now you fork the standard, right? Now when they release something with it is mapped, how do you get compatibility? Are you going to upgrade and then upgrade all of your things? Probably not, right? So things to kind of keep in mind. Look at before just jumping in, look at it. Look at your use cases, the tools that you're using. Think to yourself, okay, does this standard fit me? And again, do I need to do this? Not always. The cloud, the idea behind an old school SIEM, core-based licensing. So even on the cloud, core-based licensing means you're limited in the amount of queries you can run concurrently. Well, maybe you're running on something that's a little more serverless and you don't have to worry about that. Maybe you can just run 2 or 3 or 2,000 queries at once and merge them together. Think about these things. Don't necessarily think that, well, I did this before and now I'm going to do it now, right? Security data is finally on the cloud, so we can do something. We can do something a little bit different. You don't have to, but you can. All right, got about 2 minutes left. So showing what this looks like to query. This is probably the least interesting demo you'll see all day, all right? I could just throw everything in one table. You shouldn't, by the way, but you could just throw everything in one table. Right, I have a bunch of logs all generated, right? Normalized fields there. This is what we just showed. We can now say, okay, well, maybe I want to search for an IP address. We know, okay, source endpoint IP is what this is going to be called in all of my logs. We know that there's actually going to be additional information tied to that. I don't want to search for it now, but if you look at the OCSF spec, even an IP, it's an object, right? So taking advantage of what other people have built, okay, now we can look for an IP address and look cross-cloud. Let's take a look at all the different, we can do aggregations now that we have these kind of fields. It's not perfect, but if it's what we need for our use case, it might help, it might smooth things along, it might make your job a little bit easier. Same things here, right? Let's take a look at the cloud providers. Okay, now we've aggregated all of our activity names and the clouds and we get a count of everything. These are things that we wouldn't have been able to do before. These are things that we would have had to put into a spreadsheet, move around a little bit, export, re-import somewhere else. Having everything not just centralized but easy to query just makes it easier to do shower thoughts. So I got about 58 seconds left. I think that includes Q&A. So I guess I'll take, is that correct or is there additional time for that?
Yeah, we have a few minutes, so.
Okay.
Any other any questions?
You mentioned at the start of your talk that security folks need to start doing more things that the data bros know, or data scientists. Aside from normalization, what other tips and tricks, I guess, from the data science world do you find apply to security, both offensive and defensive, that you find?
It's a big question, but I'll answer as briefly as I can. Just learn SQL. It's not that hard. It's harder to not learn it. You know, the stuff that we need is like, you know, this is how much you can learn. The stuff we need is like here.
Is there, going beyond like normalizing just sort of field names or flattening logs and things, is there any benefit, or have you seen any projects that are trying to like sort of semantically normalize things? Like, hey, you know what? This is the IP address that probably belongs to something like an instance and a cloud provider, and that way I don't have to know the field names exactly. Like I know that this is an IP associated with some machine or something. Just higher level kind of classification, normalization.
Yeah, the idea of any kind of semantic layer on top of security data, it's still very, I don't want to say early, but this generation of it is very early. So yeah, I've seen a few different projects, a few different companies actually get started to try to do this and make sense of it. It's this whole idea of, you know, if you Google, I think a lot of them call themselves security data fabrics. So it's this whole idea of the intersection between our two industries kind of combining. There is no, by the way, data sec. Like if you search for like security data engineer on like Indeed, you're gonna find like 2 postings, you know? So it's such an early field that it's you know, we're still figuring out how to combine these two things. We know we want to, but we're still figuring out, you know, best practices.
I wanted to ask about the risks of normalization losing context. So when you look at the field, I mean, you already noted that some things will like drop the microseconds, like in the standards. One of the things that I've observed is like we tag things as IP addresses or maybe even source IP addresses.
Yeah.
But there's a difference between X forwarded for source IP at the network layer, and over. How do you, I guess, think about where we should do that? Do we need to keep both the source data and normalized data in order to resolve those kinds of things?
Some companies do. Some companies want to, and they will. So that's why it's, again, where are you doing the normalization? You lose that if you get it at the source, potentially, or in the pipeline. If you keep the raw data and you're just creating views on it, then you get to keep the raw data. A lot of the customers that I talk to, it's not one team, it's multiple teams, so that's their strategy. Keep it raw somewhere, but access it through a normalized, if that's what you need.
Any other questions? All right. One last round of applause for Jake.
Thank you.